At the geometric center of a black hole lies a calculation that the universe refuses to complete. It is a point where the fabric of spacetime curves so violently that it tears, where density skyrockets to infinity, and where the majestic equations of general relativity simply divide by zero and crash. We call this the singularity. It is not just a dense object, it is a location where the laws of physics cease to function. For decades, we have slept soundly because of a cosmic promise, a safety mechanism proposed by Roger Penrose in 1969. He called it the Cosmic Censorship Hypothesis. It reassured us that nature abhors a naked paradox. It dictated that whenever a singularity forms from the collapse of a star, it must be instantly clothed in an event horizon, a one-way membrane that sequesters the chaos from the rest of the universe. Inside, causality may crumble, but outside, in our reality, the timeline remains intact. The horizon protects us from the anarchy at the core. However, the mathematics of relativity have never actually signed this contract. When we look deep into the raw equations describing gravitation, we find a terrifying loophole. The theory allows for the existence of a singularity without a horizon, a naked singularity. For a long time, physicists dismissed this as a mathematical artifact, a quirk on paper that could never manifest in the violent reality of stellar collapse. We told ourselves that the conditions required to strip a black hole of its shadow were too extreme, too idealized. But the comfortable silence of the Cosmic Censor is being broken. New theoretical models emerging in late 2024 and 2025 are suggesting that the universe might be hiding these law-breaking monsters in plain sight. The focus has shifted to the complex process of dilatonic black hole evaporation. In standard Hawking radiation, a black hole slowly evaporates, shrinking over eons. The assumption was that the horizon would shrink with it, vanishing only when the black hole itself disappeared. But recent simulations involving dilatonic fields, hypothetical fields that appear in string theory extensions of gravity, suggest a different endgame. As the black hole sheds mass, the event horizon may evaporate faster than the singularity at the center. The cloak dissolves before the monster is gone. For a brief, agonizing moment in the life of the cosmos, the singularity stands naked. Furthermore, we are rethinking the very beginning of time. While standard stellar black holes form from dying stars, primordial collapses in the dense soup of the early universe follow different rules. Researchers analyzing the density fluctuations of the Big Bang are finding that certain pockets of matter could have collapsed asymmetrically, bypassing the formation of a horizon entirely. These primordial naked singularities would not be hidden behind a veil of darkness. They would be incredibly bright, spewing high-energy radiation and gravitational distortions that defy our current understanding. The cosmic censor may not be a law of nature, but merely a statistical tendency, one that the universe occasionally ignores. If these objects exist, we are not just looking at a heavy star, we are looking at a glitch in reality that has persisted for 13 billion years. Building on the realization that the horizon is not guaranteed, we face the catastrophic implication of what it means to look a singularity in the eye. The danger of a naked singularity is not merely its crushing gravity or its intense radiation. The danger is philosophical. It threatens the very foundation of science, determinism. In a deterministic universe, if you know the state of the universe at one moment, the position and velocity of every particle, you can, in principle, calculate the future. The past causes the present, which causes the future. This chain of cause and effect is the bedrock of all physical laws. But a singularity is a place where that chain snaps. Because the curvature of spacetime becomes infinite at a singularity, the path of light and matter comes to an abrupt end. It is a geodesic incompleteness. If you were to observe a naked singularity, you would be looking at a point that is not connected to the past in any predictable way. Because physics breaks down there, anything could emerge from it. The equations do not restrict what comes out of a naked singularity. It could emit a stream of photons, a chaotic jumble of particles, a fully formed planet, or a copy of the Magna Carta. There is no law to say what happens next. If such an object exists and interacts with the rest of the universe, the future is no longer determined by the past. Randomness, true, chaotic, causeless randomness enters the cosmos. History would lose its predictive power. This nightmare scenario is becoming plausible through the study of angular momentum. We know that black holes spin. The equations of the Kerr metric, which describe rotating black holes, show that as spin increases, the event horizon flattens and shrinks. There is a theoretical limit, the extremal limit, where the centrifugal force of the spin perfectly balances the inward pull of gravity. If you spin a black hole past this limit, the event horizon rips apart and vanishes. We used to think you couldn't spin a black hole that fast. Matter falling in would slow it down. But 2025 simulations of super-extremal spin dynamics suggest that under specific high-energy conditions, or through interactions with exotic matter, a black hole could be overspun, throwing off its cloak and exposing the core. Yet, amidst this terror, there is a seduction. Some physicists argue that the death of general relativity at the singularity is exactly what we need. It is widely accepted that relativity is incomplete because it clashes with quantum mechanics. A naked singularity might be the only place where we can directly observe the effects of quantum gravity, the theory that unites the large and the small. If we could see the core, we might see that the singularity is not a point of infinite destruction, but a quantum bounce, a region where spacetime reaches a minimum size and rebounds. Instead of breaking the universe, the naked singularity might be the window into the underlying source code of reality, showing us the discrete pixels of space and time that Einstein's smooth geometry obscures. It would be the end of determinism as we know it, but perhaps the beginning of a deeper, truer understanding of how the universe computes its own existence.